Hi there, MG5004 and DE5418. This is topic 11, class 2, where we are finished actually looking at the techniques of integration, but we're now just using them in various formulas to find things that may be useful to engineers. We've looked at mean values, we've looked at root mean values, we've looked at lengths of arcs, we've looked at the Archimedes spring, or the Archimedean spring. Now we're going to look at the volumes of a solid, where we're revolving a solid around an axis, and we'll look at finding the centroid of a shape. Right, all we have to do is find the various bits from the function that we're given and put them in the right place. We're told that y squared equals 8x. So that means that we can write that y is equal to the square root of that, so it'll be the square root of 8, which would be 2 root 2 x to the half. So then obviously we're going to need the derivative of y, so we need to find dy by dx, which would be equal to root 2 x to the negative a half. And we need to square that, so that would be 2 over x. And we also need to find 1 plus the derivative squared, so that would be 1 plus 2 over x, which we could rewrite as x plus 2 over x. So now we're ready to use the formula. The surface area for an arc being rotated around the x-axis in a complete revolution between x equals 0 and x equals 2 is going to be 2 pi times y, which is 2 root 2 x to the half, times the square root of 1 plus the derivative squared. So that's, we've already found that is x plus 2 over x. And we've got to take all of that, the integral with respect to dx. Okay, we would be best to put the numbers out. We would be best to rewrite the x plus 2 etc. to the power of a half, but notice also we've got an x to the half outside the square root sign, and this is an x to the half inside, so that's going to cancel with that. We can put the numbers outside, so then we've got 4 pi root 2 times the integral between 0 and 2 of x plus 2 to the power of a half, and that's reasonably straightforward. We'll leave it as 4 pi root 2. Now we've done the integration, it would be x plus 2 to the power of 3 over 2 over 3 over 2 between 2 and 0. So flipping the 3 over 2 to become 2 over 3, then we'd have 8 pi root 2 over 3 times, now if we put in 2 into x plus 2 to the 3 over 2, we would get 8 minus, and if we put in 0, we would get 2 root 2. And simplifying that on our calculators, it would be approximately 19.5 pi in fact exactly 19.5 pi, or approximately equal to 61.3 units. The situation is slightly changed when our function is expressed parametrically, but there's a formula for it. So all we have to do is follow the formula. We can find dy by dt being 6t. We can find dx by dt we could factorize that. We need to find the square of each of those. And the square of the other one. Squaring 1 minus t squared would give us 1 minus 2t squared plus t to the 4. And then we do everything, add these together. So we've got dy by dt squared plus dx by dt squared is going to be 36t squared plus 9 times 1 minus 2t squared plus t to the 4th. And if we do that and simplify it back, we have that. Now we've got the bits, all we need to do is to put them into the formula. So the surface area is going to be the integral between zero and 1. And now we've got 2 pi times y, which is 3t squared, times the square root of 9 times 1 plus t squared squared. Simplifying that, actually we could do it all in one go. We could take out the 2, the pi, the 3, and the square root of 9, which is another 3, and put it as 18 pi. Technical issues today means it keeps just disappearing. Okay, so that's 18 pi times the integral between 0 and 1 of t squared times the square root of 1 plus t squared squared. So that would be times 1 plus t squared. So that's 18 pi times the integral between 1 and 0 of t squared plus t to the 4. So suddenly it becomes a whole lot easier. So it's the integral, we can do the integration. So it'd be t cubed over 3 plus t to the 5 over 5 between 0 and 1, and that just becomes 18 pi times 8 over 15, which is 48 pi over 5. These two examples I will do in class. Those of you that have done the diploma or coming from year 13, you will probably remember this rule that you can use integration to find the volume where you are taking a line, in this case here the function x f of x here, and you are rotating it. There are two ways you can rotate it. You can rotate it around the x-axis, in which case the volume is given by that, and you're working it out. It's the same thing. It's summing little discs in the same way that finding the area was summing little rectangles. This is summing little discs to give you the volume for this one. So you're given the volume that's around the x-axis, and to rotate it about the y-axis, the variables are just reversed. I will do the second of these in class, but we'll do the first one here. It's simply a matter of using the formula. So it tells us that the volume is equal to the integral between 0 and pi by 4 of pi times y, and y is 5 cos 2x, and we square that and we integrate it with respect to x. Okay, do a little bit of work first. Let's take the pi out the front. And in fact, let's take the 5 squared out the front too, so to make that 25. And then we've just got to integrate cos squared 2x. And remember that cos squared cos 2 theta is equal to 2 cos squared theta minus 1. And you also remember that cos squared theta is equal to a half 1 plus cos 2 theta. Only in this case, theta is actually equal to 2x. So that will become 4x there, not 2 theta. Okay, so now we've got a half. We may as well take the half out and put it 25 pi over 2. And we're going to integrate. Now we're going to integrate 1 plus cos 4x, which is now easy. The integral of 1 is x, and the integral of cos 4x is sine 4x over 4. And doing the number crunching, it would be 25 pi over 2 times pi over 4 plus 0 minus 0 minus 0 plus 0, and that becomes 25 pi squared over 8 square units. Right? And I'll do the second one in class. As I've already mentioned, if you're going to rotate the line around the y-axis, then it's the same kind of formula. You've just swapped the x's for the y's. Neither of these are very difficult. For the first part, v is equal to the integral, I'll take out pi, between 1 and 4 of x squared plus 4 squared. And the only thing there to remember is that you need to actually multiply out the x squared plus 4. And follow through that. So if you follow through that, that is 420.6 times pi cubic units. And the other one says to, the second part of the question says to revolve the line around the y-axis. So this time all we have to do is find the limits on the y-axis. You can see them from the diagrams. It's between 5 and 20, and it's got to be times x squared. Now x squared, so we've got y equals x squared plus 4, so x squared must equal y minus 4. So it's the integral between 5 and 20 of y minus 4 times pi and going to do that between 20 and 5, and the answer would be 127.5 pi cubic units. So again, we're not doing any new techniques, we are just simply finding the appropriate formula and using it. I will do this question in class. Here is further work where we simply have to use a formula that involves integration. The actual integration is not difficult, we just have to use it. And there's two ways of finding the centroids here, where we're looking, the figure is, in this particular case, the figure is this one in here. So we're finding the figure there, and the other sort, for which there are different formulas, is finding the centroid of the plane between the curve and the y-axis. But it's not difficult. If you need them, you will be given the formulas. Now, just a point to note here that the denominator in each case is the area of the figure. So that actually the x coordinate is equal to 1 over a times the integral between a and b of x, y dx, and that the y coordinate is 1 over 2a, because it's got a half on the top line, times the integral between b and a of y squared. Now, the only complicating thing is that sometimes you have to find y squared, or sometimes you might have to find x. So look at the problem individually. I'll do this one in class, but if you want to have a go at it, what you need to remember is that y squared is e to the 4x, given that y is equal to e to the 2x. But I'll do this one in class. We can also use integration to find the centre of gravity of a shape, of a solid shape, where we're rotating a curve around an axis. Again, it's just using formulas. In this particular case, it's rotated around the x-axis, and it's symmetric thus about the x-axis, so that the centre of gravity, the y-coordinate for the centre of gravity is going to be 0. Now, the text has a slightly different version from the one that we've got here, but if you just think about it, the text, I think, says, or some texts say, that this is the formula. But that's fine, because in actual fact, v is equal to pi times the integral. I should put a and b in there. Of y squared. So it's the same. Okay, so you can do it either from scratch, or if the question has already asked you to find the volume, then you can use the second version and just put the volume that you already know outside the integral sign underneath the pi. Not the right textbook pages, but let's do the working. The x coordinate, now this is rotated around the x-axis, so the y coordinate of the centroid, centre of gravity is going to be 0, so we can already do that, and the x coordinate is going to be between B and A. This is just writing out the formula again. So it's just a matter of doing each of the bits separately. So if you were to do the top line, will be the integral between 1 and 3 of x times y squared, and y squared is going to be 16 minus x squared. So you would multiply that out, integrate it, and the answer would be 44. You would also need to do just the integral of the bottom line. So that's the y squared, which is 16 minus x squared. And if you integrate that and plug in the values, then you're going to get 23.5. So the x coordinate then is going to be 44 over 23.5, which is approximately 1.89. So our centre of gravity is going to be at 1.89, 0.